everyone, today we'll be doing the flight control challenge. This is our glider without any control surfaces. And during this challenge, we'll be creating 3 types of control surfaces for our glider. This is to explore how they can alter the aircraft's orientation. First of all, we'll add small tabs of sticky tape on each side of the tailplane. This is to make elevators for your glider. Next, we'll bend these up and see how this alters the pitch of the glider. Now, let's explain what happens when the tabs are bent upwards. For the effect, this causes the elevators to deflect upwards. For the aerodynamic change, the airflow is directed downwards behind the tail, creating a downward force, also known as the nose-up pitch. And for the tail force, the tail produces more downward force, which increases the upward moment at the nose, causing the glider to pitch up. This increases the angle of attack, making the glider climb and stall if the angle becomes too high. Next, I'll explain what happens when the tabs are bent downwards. For the effect, this causes the elevators to deflect downwards. For the aerodynamic change, the airflow is directed upwards behind the tail, creating an upward force, also known as a nose-down pitch. The tail produces an upward force, which reduces the nose's upward moment and causes the glider to pitch down. This decreases the angle of attack, making the glider descend. On to our next question, we will add tabs on the back of each wing near the tips. This is to make ailerons for your glider. Turn one up a little and the other one down. So, here's what happens. For the tab on one wing, the airflow will create less lift on the wing because it disrupts the smooth airflow, decreasing the wing's ability to generate lift. And for the tab down on the other wing, this wing will experience more lift because it enhances the camber of the wing, improving its lift generation. Now, let's see what happens if we reverse the ailerons. Now, when you reverse the ailerons, the glider will roll in the opposite direction. So, the wing with the tab up will drop, and the wing with the tab down will rise, making the glider roll to the left. Now, let's explain the lift force on each wing. For the wing with the tab bent upward, it will generate less lift on that wing because it creates turbulence and disturbs the airflow, causing the wing to drop. And for the wing with the tab bent downward, it will generate more lift as the camber increases the wing's efficiency in generating lift, causing the wing to rise. to our final question, we'll put one tab on the rear of the fin so that it can be bent to one side or the other. This tab is a rudder. It can be used at the same time as the ailerons to turn the glider. The left aileron should be bent up. The right aileron should be bent down. And the rudder should point left. So, why does this happen? I'll tell you what happened. The rudder changes the direction of the glider by altering the airflow around the fin, causing the glider to move in the opposite direction of the rudder, which makes the nose of the glider turn in the desired direction. The ailerons work together with the rudder by adjusting the lift on the wings to create a roll, helping the glider bank into the turn for more stability. Now, using both controls together helps create a coordinated turn where the glider doesn't just roll, but also points its nose in the correct direction, making for a more efficient and smoother flight path. Now, that's all from us. Thank you for watching. This is SMK Sultan Alauddin.